Hello everyone, I came across this question today and thought it was worth analyzing. Do two identical wires, one at 12 volts, one at 220 volts, each passing 20 amps, generate the same heat? Let's find out. And here's our two circuits. One's at 12 volts, one's at 220 volts. They both are using wires that have a resistance of 0.1 ohms and are both attached to loads drawing 20 amps. Let's remember our three basic equations for power. Power is equal to voltage times current, power is equal to current squared times resistance, and power is equal to voltage squared divided by resistance. We know that the voltage here at both the voltage sources are 220 volts and 12 volts respectively, but once we cross to the other side of the wire at the load, we don't know what the voltage is because of the voltage drop across the wire due to the resistance of the wire. So that means that the equations relying on knowing this voltage drop, we don't have the information, we can't use it. That leaves us with power is equal to the current squared times resistance. We know what the current is, we know what the resistance is, so let's plug those in and find the power loss across this wire. That's 20 amps squared times 0.1 ohms, and that gives us 40 watts of power lost in each of these wires. So 40 watts going to the load and 40 watts returning back to the supply. So that's 80 watts total of power loss in this first example. And if we go down to the 220 volts, again, we know it's 220 volts here on the left side. We don't know what the voltage is here on the right because of the voltage drop across this wire here. So again, we'll use the 20 amps, 0.1 ohms, and that gives us the same 40 watts. I know several of you are wondering, 220 volts, that's roughly 18 times as much as 12 volts. Power is equal to voltage times current. That's a lot more power. Where's it going? How is this possible? Let's look at the power going through both these loads. And in order to do that, we need to know what the voltage is on both sides of this load. In order to do that, we'll need to use Ohm's law, which is V equals the voltage across this resistor is equal to the current times the resistance. We know that the top of this voltage source is going to be 12 volts. The bottom here is 0 volts. We need to figure out the voltage up here on the right. That's going to be 20 amps times 0.1 ohms is going to be 2 volts drop across the resistor. So that means up here is going to be 10 volts. And here on the bottom side, we've got to have, it's still 20 amps flowing across this resistor. It's still 0.1 ohms. That means there's got to be a 2 volt drop across. And we've got 0 volts here on the left, so it's going to be 2 volts here on the right. And we'll do the same thing here for the 220 volt circuit. That's 220 volts on top, 0 on the bottom. It's still 20 amps flowing through, 0.1 ohm resistors. That's still a 2 volt drop. That leaves us with 218 volts on the top and 2 volts on the bottom side of this load on the right hand side. Now let's remember, power is equal to voltage times current, and that leaves us with the voltage on the load here is 10 volts minus 2 volts, and we multiply that by the 20 amps. That leaves us with 8 volts times 20 amps, which is 160 watts. So there's 160 watts being dissipated through this load on the 12 volt circuit. Now let's go to the 220 volt circuit, where the power being dissipated through this load is 218 volts minus 2 volts multiplied by 20 amps. This is 216 volts times 20 amps, which is 4,320 watts. That's a lot of power. Now let's look at the power on the source side. So that's going to be 12 volts times 20 amps, and that's 240 watts. And down here at the 220 volt supply, that's 220 volts times 20 amps, and that is equal to 4,400 watts. Now let's make sure that all the power is accounted for. So the 12 volt supply is supplying 240 watts. We're losing 40 watts here on the first wire to the load. The load itself is dissipating 160 watts, and we're losing an additional 40 watts on the return to the voltage supply. The 40 plus 160 plus 40 all add up to equal 240 watts. So all of the power is accounted for. And down here at the 220 volt supply, it's generating a whopping 4,400 watts. It's still losing 40 watts on the trip to the 20 amp load. The load itself is dissipating 4,320 watts, with an additional 40 watts being dissipated on the way back to the supply. And again, the 40 plus 4,320 plus 40 watts is equal to the whole 4,400 watts being supplied by the 220 volt supply. And everything's accounted for, nothing's missing. So what's the conclusion from this? The answer to the question is yes. The same heat is generated whether the wires are being energized to 12 volts or 220 volts. It all is dependent on the current flow through the conductor, through the wire. Hopefully this answered your question. If it caused any new questions, please put them in the comments below and I'll try to get to them as quick as I can. Thank you very much. Have a great day.